are not local, if you go onto YouTube and you put in Pacific Yacht Systems, there is hours of Jeff's presentations for all sorts of different things in electrical. The amount of knowledge I have gained has actually been fantastic. So for folks who are not familiar, if you go on YouTube, Pacific Yacht Systems, there's just hours and hours of lectures, and Jeff is very good at explaining things.
Which one?
Finding out what's supposed to happen. So I'll pass it over to you. Thanks.
Yeah, thank you. Thank you. Thanks everyone for having me here today. I know it's the end of the day. Hopefully my energy is going to carry in the room. It's absolutely gorgeous outside today. Energy level in Vancouver is off the charts. It's what we live for here. And we're actually feeling it as well within the market and people kind of calling us to talk about voting. So I've made my life's passion, maybe someone want to adjust the adjuster? Yeah, yeah. So my life's passion is marine electrical systems. I'm a boater through and through, sort of everything I do, everything. I own a business and we're 15 of us now. And what I'm going to be sharing with you with today is sort of what we all see in the field, which is boating is full of surprises. And things are not necessarily done to code on boats. And as part of our business, we do what's called an electrical audit, which is not what surveyors do, but it's sort of just focused just on electrical. Some of them can be 6, 7, 8 hours just on electrical systems on big boats. And some of them can be just a couple hours. And that's all we do is just electrical because we don't know anything else but electrical. And what I'm going to share with you is going to be all the common deficiencies that we encounter when we do audits aboard boats. Feel free to raise your hand, anybody in the room, as I go along, and we talk about all these sort of building blocks of electrical systems. So we're going to be looking at sort of the common building blocks, and I have on our website, and we've got, you know, now we're probably at about 200 videos on YouTube on sort of deconstructing an electrical system in a boat into simple, as an engineer, things that you can build. I used to remember liking Legos when I was a child, and a boat is just a combinations of a lot of little parts. So that's all it is. It's complicated, the system is hard, but the building blocks aren't hard at all. So what we're going to be looking at is the most common building blocks of the electrical system on a boat, and what are the things that we find that aren't up to code and also don't make a boat reliable, which is very frustrating as a boat owner. And that's why I'm here today. My boat was, I bought it on April Fool's Day 12 years ago. And it was the best moment of my life and also the worst moment of my life when the boat was constantly breaking down. And I decided to tame this beast. So first we're going to start with, these are all the different things that we're going to talk about looking at batteries. This is sort of a little bit of a list. We're going to talk about battery connections per se, the different types of battery types that we see aboard boats, and what's even more surprising is the wrong battery type used for a certain application, like for instance using a starter battery and a deep cycle application. I get about a dozen calls in the summer of batteries that explodes. It's generally from a new boat owner that bought a boat, and that boat owner was sold a boat with starter batteries used for deep cycle applications, and they didn't know. And eventually the plates got, you know, the battery went dry, and things went kaboom. We're going to talk about the wiring at batteries, the battery boxes. That's a crazy, crazy world. How people don't understand what to do with a battery box or what the purpose of a battery box is. As we know, it's very frustrating. A lot of things with boats don't come with a manual. You know, you buy a battery box, there's no manual on how to install a battery box on a boat. You have to read Nigel's book, and you have to figure out what's the purpose of a box. Is it a container? Is it just to look good? Is it to hold the liquid inside the box? So we'll talk about that. And also about fusing. This is all too common. People look on the right-hand side. I see this all the time. People think that stainless is conductive. They put stainless in between what is the lug here in the middle of the diagram, and this is a very high resistive circuit, right? This is not copper. Stainless is not copper. So the stacking of connections on a fuse block is integral, right? And you'll see this. Like, think about an ANL fuse. You know, on one side it's a fork, and on the other one side it's a hook. You take it out of the fuse block, but if you don't stack those washers in the right order, and you literally put washer, fuse, lock washer, nut, you're actually defeating the whole purpose. You just put a high amperage resistor right into the circuit. And I get called on boats, and the fuse block is melted through. Literally, the fuse block melted because why? Because the stainless steel washer was used as a resistor in the circuit, in a high amperage circuit. So stacking is absolutely essential. A lot of folks also don't understand the concept of that the largest connection should be the closest connection to the most conductive surface. I see this all the time. They'll stack from the littlest, smallest connection point, like a 15 amp, like a gauge, I don't know, 1822 terminal, and then they'll put a smaller one. And then at the end, after 4, 5, 6 terminals, and there should only be 4, they'll put a big high current connection at the top. And I said, think about the pyramids. You know, they put the smallest block at the bottom and the biggest blocks on top. Stacking of terminals is everything. No manufacturer decided to build a terminal and said, oh, by the way, I'm going to have your starter circuit go through a gauge 1822 terminal so that you can get to the battery. So these are little details that you can tell an owner. And the world of electrical is a world of detail, right? It's perfection-based world. If you don't like details, I tell my owners all the time, don't touch it. It's like being an accountant and not liking numbers or perfection. That's not your business. This is not carpentry. You can't be half right, 99% right. It's 100% right, or you're not right. Question.
I think you're assuming too much from your audience here. In terms of that picture, you said that those little washers should be on the other side.
Yeah, right here. Yeah. So they should be on the other side, because right now, this is the battery terminal right here, right? And you've got stainless steel washers, and this is a lug right here. So the stacking of these washers in between what is the battery energy and what this is sort of the negative terminal going to any load, could be a starter, could be an inverter, could be a negative distribution. Now, basically, they basically put an amazing amount of resistance in that circuit. So the voltage drop under load is going to be tremendous. The battery is not a problem. It's that they put a high resistive circuit right into the circuit, right here. This would, I've never read that. Nope. Yeah? Stacking, yes, but not putting stainless washers. No. That's just simply being an electrician. No. You know, the world of boating is full of pitfalls, right? If it was easy, none of us would have a job. I certainly wouldn't. I mean, boats would just work. And I'd be boating. And I'd be happy. Now I'm in the profession. Yeah. So, yeah, stacking, it's all about, and remember, a big one too is there's these really popular fuses now. Blue Seas has them. They're called MRBFs, marine rated battery fuses. They're sort of battery fuses that look like an L, right? So it allows you to do a fuse directly on the battery. And again, the stacking is essential. Every time I see a MRBF battery fuse, I'm like, did they stack the stainless steel washer at the right place? Because if they put it below the fuse and they went fuse holder, stainless steel washer, fuse, and then they put nut, again, they put a high resistive resistor. They put basically they're blocking the circuit. And then under load, voltmeter is going to be fine. Voltmeter is going to see a voltage, right? It's easy to have good voltage under no load. People don't have a heart attack in bed. They have a heart attack shoveling snow, doing high intensity cardio. So remember, voltage is never an indication of a good circuit or not, because voltage under no load is irrelevant. It's a sign, you have something, but are you going to be able to sustain it under load? So that's where those problems drive people crazy. I have good voltage. As soon as I turn the load on, voltage drops. I bring the battery to the manufacturer, the battery's good. Where's my problem? And then that's where people lose confidence in their boats. Lead acid battery type. This is an example of a battery that exploded. What happens is, we see this all the time. Sellers are motivated to keep costs down. Brokers are motivated to appease sellers that feel that this journey of boat ownership has been too expensive. And they're faced with a choice at a battery store, buying a deep cycle battery, which is 2x, 3x the cost of a starter battery, or buying a normal battery, which looks like the other battery, at a fraction of the cost. And a seller is generally pretty motivated. It's not the happiest day of their lives or the happiest 6 months or a year of their lives. So what they end up doing is they end up installing starter batteries on deep cycle applications. Because to most people, an 8D is what an 8D, right? It's a battery. But a starter battery and a deep cycle battery are completely different batteries. They look the same on the outside, but they're completely different. So one of the biggest things I do when I do an electrical audit is I make sure that every single house battery has a house battery connected to it. And if you don't do that, you'll find out that over time, as they're using their starter battery for deep cycle applications, that battery was not built for that. And as we recharge a battery that wasn't meant to be deep cycle, it will start sweating, right? It has a hard time to re-energize those battery plates. And what that does is the battery starts losing all of the electrolyte. And new owners don't understand how quickly they should be maintaining their batteries. So they forget to top off the electrolyte. The battery of the electrolyte goes a lot faster than it should have because it's the wrong battery for the application. And that battery, eventually, the plates actually start warping. And as soon as 2 battery plates warp in a container that has no more water and is full of hydrogen gas, it's a bomb. And I've literally get calls every summer of hatches that get flown off at the back of a deck, literally for no other reason that there was a starter battery used in a deep cycle application. I don't mean the battery box blew up. I mean the hatch at the back of the deck that was covering that area literally flew off the hinges. That's how strong the explosion was. Because hydrogen gas is not a joke. And why? Just because somebody decided to take a shortcut. So make sure when you're inspecting a boat that you're looking and finding out if it's a deep cycle battery for a deep cycle application. Yeah, it will. Yeah, it should. And if it doesn't, then put a big question mark saying unknown battery type, right? Recommend to replace unless confirmed to be deep cycle battery.
Jeff, that photograph on the right-hand side, is that indicating that what you're saying, the battery's sweating?
Yeah, I was going to talk about that next one. That's a good question. Yeah, 2 different things. So if you have a flooded lead acid battery, and I get this all the time, people tell me, oh, it's moisture on my battery. I'm like, all right, let's pretend that you have a special environment where your battery is a different environment than the rest of your engine room. If it sweats in one place, it's got to be sweating everywhere. The battery can't be the only thing that's sweating, right? And most owners or sellers want to say, oh, no, that's just water. That's not water. That's sulfuric acid. And sulfuric acid comes out of batteries for multiple reasons. One is the battery got overfilled, right? It's pretty common. Most people don't understand where to stop filling a battery at the right level. So that's pretty common. And the other one that happens is with age, battery chargers are shooting for typical charging voltages, what they consider to be nominal charging voltages, like 13.4, 14.4 at 12 volts. These are typical ones. They are not adjusting for battery age, ever. They're just assuming, like, you know, people say humans take 2,000 calories per day. That's an average consumption for an average person. But when you're 14 years old or you're 75 years old, your consumption is different. Batteries want different charge rates based on their age, but chargers can't do that. It's not Star Trek. So as a battery ages, that battery has an inability to take the same charge current as it did before. And as you're pushing a voltage that this battery can't take easily, it starts sweating. As it sweats, it heats up. And as that heats up, anything that heats up expands, right? That's the concept of hot air balloon, right? And as this liquid heats up, it actually vents and comes out through the vent cap. So if you have, and we'll talk about that a little bit later, but if you have flooded lead acid batteries and you have electrolyte at the top of the batteries, it's sign of two things. Either the cells have been overfilled, which happens a lot because it's not that easy, or the battery is showing signs of overcharging, right? The chargers have failed, and they do sometimes fail overcharging. Pretty rare, happens. Or wrong setting on the charger, happens a lot, right? Charger settings are often overlooked because, you know, I mean, it's in a manual, they don't get it. It's not, again, not their fault, but it's pretty hard. Or the battery is old. But if you see sulfuric acid on top of a battery bank, that's a big telltale sign that there's a problem. This is an example of what someone should do, right? You can see that here there's actually a lock washer, right? No lock nut, right? Everything is tinned terminals, marine terminals. Good heat shrink. You'll see a lot of people buying heat shrink and they're thinking, if I can make it as short as humanly possible, I've met the code. I've seen people cut heat shrink, I am not joking, 1/4 of an inch. It's barely a belt on the connection point. I'm like, why bother? Why bother? 1/4 of an inch? Do you know how tricky it must have been to align that over the seam? It's not, you know, you're not trying to look cool by dividing your pants with your sweater. You're trying to insulate the connection from any moisture from happening. And this would be the opposite of good, right? We see that a lot. People do crimps, they just get it done, show bare wire. So I'm always looking for 2 inches of insulation on the connection. As far as reasonable is about here, you can't go 1 inch on one side, 1 inch on the other, but you're gonna go probably 1/2 inch on one side and about 1.5 inches on the jacket of the wire. And you wanna make sure that these sort of connections I always identified as to be replaced. There's nothing too sexy about batteries, but it's like the foundation of your house. It might not be the most amazing thing on the boat, but if you've got bad connections of the battery, you've got a world of hurt through and through on this vessel for everything electrical, because it starts at the battery. Without good connections of the battery, everything else is going to act weird when the voltage starts dropping and you're away from the dock. Battery boxes. Battery boxes are probably one of the most misunderstood appliances, devices on a boat, electrical system, bar none. And it's unfortunate because most people think it's probably some sort of device to stop the batteries from moving, or to hide them, or to protect them against accidental shorting. But the real purpose of a battery box, first and foremost, is to contain electrolyte from a flooded lead-acid battery bank. That is the #1 reason why we have battery banks. And I've been blessed, you know, to work on thousands of boats, doing thousands of electrical audits, and I can tell you that less than 20% of boaters have battery boxes that are properly mounted in a boat. If you want to look for a #1 thing electrically that's been badly done in a boat, as soon as the boat leaves that factory and it's the world of do-it-yourselves in the yards where people have a huge scope of work and have limited knowledge, it's not that they're not smart, it's they're asked to do so much. Battery boxes don't come with manuals, and nobody takes the time to read a book, unfortunately. And I cannot tell you how often I see this, where there are literally screws drilled in the bottom of a battery box. And that defeats the whole purpose of buying the battery box. It's like buying a glass and drilling a hole in the bottom. It's not a container anymore. An electrolyte will never neutralize itself unless it meets a base. It will just it's going to be there forever. It's an acid. And I've seen boats where the damage is so insane, goes right through, eats the screw, goes through the screw, doesn't do anything to fiberglass, because most boats have, you know, boards, right? And it's glass on either side. Goes in the wood. The wood is what? Porous. Porous means it has the ability to wick moisture in all directions. We worry about that with decks, right? All the time. And that's your world. Moisture goes in all directions, and sulfuric acid destroys the cellulose of the wood, makes it like papier-mâché, and then basically you have a battery box that's on top of something that got completely eaten by sulfuric acid. Why? Because somebody miraculously decided to defeat the purpose of a battery box by putting fasteners in the bottom of the box. If the box looks like it's miraculously held into place, it's held by fasteners. And most people always tell me, oh no, it's the weight. I'm like, no, this is not a condo. This boat moves. It's not moving right now, but I can tell you the ocean is not always flat. I can guarantee you that. And if you haven't lived it, just wait. You will see that the ocean is not always flat. And one day this boat will be sideways. And those batteries do not stay in their place if they're not held down. And that's why you think about a Grand Banks, they've got this really nice bevel all around, right? It's almost like 2 inches, 1.75 inches of wood all around their beautiful battery boxes. They put these really nice battery boxes. They put a sort of a tray around it, right? I mean, can you imagine how much that cost the builder to do? Those battery boxes, not a single screw within them, right? It was perfect. They did a tray for it, put the battery box in, and then they would hold the battery into place with straps. A perfect battery box. Builders know what to do. They do. They have to. Otherwise, we wouldn't be buying their boats. It's what happens past the factory. The do-it-yourself crowd. Those are the people that we as working in the industry have to worry about. The people that aren't educating themselves. So look out for this. If the battery box is miraculously held into place, and I'm telling you, over 80% of them are done wrong. You know, I've come to realize that electrical systems are hard. And if you're an installer and you have a choice between installing a connection and a DC panel, and most of us have seen the back of a DC panel, and they don't look too inviting, let's be honest. If you feel comfortable looking at the back of an AC or a DC panel, you're a very fortunate person. Congratulations, you're doing pretty good technically. Most humans would look at the back of that and say, I'm not going there. There's no way I'm going there. There's no way. I don't know what they look at it. They're like, close it back up. They're like, where's the battery? Let me go back to the battery. I know what a battery is. And they're going to go back to the battery and they're going to bring all their connections, their downriggers, their fridges, every new appliance that goes on that boat, their stereo, everything that is new on that boat is going to go back to the battery. Why? Because they understand it. It makes sense. It's just a positive and negative. And then they start adding connections. The most I've seen is 15. 15. I've seen instances where the nut was not a quarter turn. I can't imagine the amount of cheerfulness that person had when it was able to get a quarter turn. The pressure, this was a multi-person operation. This was not easy. And they walked away and they said, yes, I did it. And they must have been extremely satisfied. Yeah, floating. So what you're looking for when you're looking at batteries is you got to say the max connection is 4 everywhere, certainly 4 on a battery. And honestly, I tell people, I say, this is not a distribution point. This is a battery. This is, look at your car battery. How many connections are at your car battery? You think there's only one circuit in your car? There's a lot of circuits in a car. They are not at the battery. They are at distribution points throughout the car. They have fuse blocks. And so I encourage owners, when I see that, I say, I put on the recommendation, install positive and negative distribution blocks, the way builders do, right? Unswitched, close to the batteries, bring all those terminations to there, and that's a recommendation. Battery installations and battery switches. Unfortunately, again, for us, people don't understand the purpose of a battery switch. To them, it's an annoyance, to most. Something they have to remember to turn on or off. And what you'll find a lot of is you'll find engines that have battery switches that have been removed because the circuit was too long to the battery switch. And you'll have, quite often, a lot of engines have a direct connection, unswitched, to a battery. That is a huge no-no. Massive no-no. If you have a stuck starter on your boat, turning off your ignition switch will not solve this problem. Every single fuel tank, I don't care if it's a Cote or not, should have a fuel shutoff valve. every single battery has to have an on-off battery switch. You need the ability to go in there and disconnect most loads from a battery. There are exceptions. Bilge pump, unswitched. Carbon monoxide, unswitched. Stereo memory, unswitched. A starter is no exception to a switch. It might be unfused, but certainly never unswitched. Yeah, the boats I do, I put a switch on every single circuit. What is it?
I don't remember the number exactly, but it's mentioned clearly.
Yeah. Yeah. Does anybody know? Yeah. You have no ability to isolate a battery in the event of a problem. You better have your life suit on. There is no amount of fire extinguisher that will save your life. Pardon? Yeah. And it's common. The other thing too that you'll see, and I don't know if the code says it or not, but putting a battery switch in an engine room beside the engine, who's going to go down in an engine room when the starter's on a dead short and the cable's melting? Go down the engine room to turn off a battery switch. You'd have to have a pretty courageous someone, and your partner would be pretty oblivious to the risk and death and peril that you're about to go under. You open an engine hatch and it's full of smoke. There is no way anybody's going to go down that engine room blinded, can't breathe, can't see a thing, and going to go find a battery switch in an engine room to isolate a starter from a battery. So that's why you see all these boats have battery switches on the outside of the engine room, right? Grand Banks did that for years. I mean, they were doing this in the 80s. This is not new, right? So the location of the battery switch is essential. Having it conveniently located beside the starter is great for the mechanic if they're working on the starter. But if you're actually putting a battery switch for operability of the user and or for safety of the boat operator, that's going to be a big problem. So at the very least, I would make a recommendation. And I don't know, again, the world of surveying, but I was in Calgary the other day, last year, doing a presentation, and one of the attendees was a field engineer working in the oil sand. And he reminded me, and it's amazing because in the marine world, we forget this. It was so refreshing. I had never heard it. He says, you know, Jeff, he says, the code is the minimum. It's not a high bar that we all lofty want to achieve. The code is the very least you could possibly humanly do. And in the marine world, our owners are almost making it sort of this lofty ideal. Like I should eat only healthy. I should exercise every day. I should be nice to everyone. The code is not a minimum, like this unattainable objective. It's this very low bar, and everyone should try to be much better. And that's what I encourage my owners to think about is, no, we're not trying to be just, doing it for goodness sake. We're trying to be safe, right? So we're going to always do more at the very least and not do the minimum. And so the location of the battery switch would be a really good recommendation for people. Stuck starters do happen, by the way. I get called in for fires, insurance claims, and it's a real thing. It's not a dream situation that never happens. And people lose boats because of it. It really does happen. Connections on batteries. Unfortunately, we talked about a little bit earlier about how most people look at a DC panel and are probably terrified, and rightly so. It's pretty intimidating. It's not your business. And they bring connections directly back to a battery. And again, for most people, unfortunately, if it works, it's good enough. And there are very few exceptions to not fusing a wire, right? Pretty much all circuits should have a fuse. The code has exceptions for starter. Exceptions doesn't mean you can't put one in. We've put the right fuses in the right applications. You don't have to, but everything else pretty much needs a fuse. And most people don't understand. You'll get a lot of pushback. They're like, oh yeah, but my panel's fused. I'm like, yeah, but your panel's all the way over there. What about the downrigger that's right connected here? Your stereo, your big amplifier stereo that was installed by a car place that just brought a number 2 wire directly to the battery, unswitched, unfused, installed with literally stereo wiring, right? Not marine grade wiring. That has to be fused. They're like, oh no, there's a fuse in the amp. I'm like, no, that's the fuse for the amp. What about the fuse for the wire? You got to start at the beginning of the circuit. You will get tons of pushback, tons of pushback. You're exaggerating. You're too safe. The world of boats, a crazy world. Fusing is essential. And also the right fuse for the right job. How many people oversize their fuses on inverter circuits because they keep blowing the inverter fuse? Because they have a 1,000-watt inverter and they had the right fuse at the beginning, but they're loading it up with more than 1,000 watts. And so they have a larger size fuse than they want because the other one was annoying them. It's always blowing. And then you'll start seeing that when you look at fuses, you'll see tarnishing of the fuse. You'll actually see the fuse got so hot on some circuits, that's a sign that they're running at pretty much near line rate too often. So look for connections that are also overheated, that look tarnished, and making sure that it's the right size for the right fuse. Too often than not, they'll put larger fuses than the gauge of wiring that it's protecting. Happens a lot, especially with inverters. People have a hard time understanding that a fuse, you should have a fuse for the wire and a fuse for the appliance. And if you have one fuse for both, then it should be protecting both. But you can't just choose an or, right? The wire and the fuse, or the wire and the appliance have to be protected by a fuse that is no greater than what the amperage of the cable can handle and what the amperage of the appliance can handle. Inverters are full of that, full of that. Okay, any questions on the craziness of batteries and what to look for? Yes, I've got 3 questions in the room, so I'll do it one at a time. The wing nuts? Again, I would say absolutely not. I tell everyone to take it because of vibration-prone environment. There's no way, every single wing nut I put in, I'd say you have to absolutely, utterly change that. I know batteries come with them. I tell people you got to put a nut, and if you're better, a lock washer and a nut. Wing nuts have no place. Pardon? What were you going to say, Sarah? It's crazy. You should never use your hands to tighten a 2-watt connection on a battery. By the way, remember, those cables do not want to stay there. There's not a single battery cable that happens to be landing in the location where it is. I mean, that's like the lottery. It could happen, but all of them are under tension and they want to go somewhere else. There's not a single time you have a battery connection. It's like, oh, look at the curvature and the bend. It was perfect. It actually just landed there. No, it wants to go somewhere else. So you have a wing nut, and we know that boats are vibration-prone environments. Those wing nuts get undone. I was on a boat once, and there was 12 golf cart batteries with wing nuts. 8 of them had lost their wing nuts. 8. Literally fallen off, gone off to the side. I was called in because the battery bank was not giving them the appropriate amperage. Luckily, they had wired it wrongly off one battery, well, 2, and everyone else was just daisy chain afterwards. But 8 of the 12 were actually simply disconnected. They had been abandoned by the wing nuts because as soon as the wing nut undid itself, the wire just jumped back up to some position which wasn't where it started. So that's my recommendation on wing nuts. Go ahead, Sarah. Can you speak louder for the mic? Oh, yes. And it also eats keel boats. I have an owner that lost 2 aft keel boats on their boat. Now you can only imagine that is not an inexpensive surprise. Question? Pardon again, can you repeat that? Well, it has to be a battery box. The question is, what is suitable for a battery box material? It has to be, generally plastics are good because they're inert. If you have a wooden battery box, it has to be literally fully epoxied, like completely epoxied, and epoxy becomes effectively glass. But there can't be a fastener on top of it. Like on my boat, I have a battery box that I created from wood. My fasteners are glassed underneath. They are, like, if I take the battery box, I'm gonna have to take a chisel. Like, it is liquid tight. It has to be completely inert. So battery boxes that are made of wood, not good enough. It needs to be glassed in. Takes time. People don't have time. They love shortcuts. Any other questions on batteries? Yes, go ahead.
Some of these things aren't necessarily even good stuff. I have a brand new pair of keyboard that is $3.5 million boat. Battery switches are inside the engine room with an electrically only driven hatch to get into.
Generally, yeah. Well, luckily we'll have jobs forever. Our job security is guaranteed, I can tell you that. Guaranteed. You do never have to make work in this industry, ever. There is work happening every day. As we speak right now, people are planting bombs, clearly seeds of destruction everywhere. And it's not because I'm not trying to educate. It is happening every day, everywhere. Yes?
I know ABYC standard doesn't differentiate between lead acid and AGM or battery box, but in your experience, you had a battery box with fasteners through the batteries or AGM style, would you still push for replacement battery box?
Good question. Let me try to paraphrase the question. So if you have now, they are lead acid batteries, but they're AGM, absorbed glass mat batteries, right? So it's called a seal valve regulated battery, but the battery can't leak, right? So if you have a battery box that has been compromised, right? Someone drilled holes in the bottom and you have AGM batteries within that box, what would I recommend? And the long list of things that if someone has to worry about, I would put it at the very bottom of the list. And just realistically, that battery can never leak. So therefore, it's really great to contain the batteries. It's great for accidental shorting of the battery posts, but I would not make it at the high priority item. If it's an AGM battery within a battery box that has been screwed within, you know what? Yes, in an ideal world, yes, but ideal worlds in boats, very few people can have an ideal boat. Very few. So I would bring it way down in priorities. Yes, question? I had, lose a second. Yes, go ahead. You had a question? No? Okay, go ahead. No, it's fine.
AGM batteries, is that what car batteries are? Like, I understood you don't have to add water to both modern car batteries. Is that right? Is that an AGM battery?
Yeah, so now we're, okay, so by the way, I love what I do. So I just want to say the doors are not locked. Okay, so we could be here for literally 12 hours. If I go in the rabbit hole, I will go there for 30 seconds, but only 30 seconds, because batteries are topics. We could do an 8-hour presentation on batteries. Batteries come in different types: lead acid, flooded; lead acid, seal valve regulated; AGM and gel, Firefly, carbon foam batteries. Lead acid batteries can all, flooded can be by maintenance free, which is an oxymoron for you forego maintenance and you don't have the ability to maintain the battery. It's a marketing scam, in my opinion. Someone in a room made a really evil joke and they actually are selling it to the public. And then there's actually maintainable flooded lead acid batteries. There's no such thing as a truly maintenance-free flooded lead acid battery. It's a battery that you cannot maintain. So it's a marketing scam. It's a joke. Every flooded lead acid battery can be maintained, including a starter one. Deep cycle ones absolutely need it. And a starter battery doesn't necessarily need it as long as you never, ever, ever discharge it deeply. The moment you discharge a flooded lead acid starter battery deeply, when you recharge it, it will sweat. It will heat up. And if it's sealed, codename maintenance free, you will never have an ability to top off the electrolyte.
What is your view of lithium-ion? This day and age?
Yeah, I'm gonna leave that to now, because now that's locking the doors type of question. No, we're not going there. I'm not gonna fall bait to that. No, we're staying on track. No, not happening. Another day outside. All right. Okay, battery chargers. So battery chargers, we've got to look at circuit protection and the location of the charger, of where that fuse is. By the way, fuse location is mind-blowing to every single installer. Like, it's a fuse to them is sort of this magical device that protects things on either side of the circuit. Okay, like fuse location is the most misunderstood thing, including chargers. By the way, we're going to talk about that. Where chargers should be mounted, the concept of a grounding wire on a battery charger, oh my God, 98% of battery chargers do not have a chassis ground. Why? Because you don't need one until you do. The connections themselves, the size of the charger, and the settings on the charger. You want a world of hurt? Look for a charger. It is full of surprises. It's full of surprises. So first of all, the connections themselves, battery chargers, and this is, you want a world full of surprises and a world where your boat is magical. Connect your battery charger leads to a switch distribution, meaning not directly to the battery, but when you turn the battery switch off, the charger leads are on the load side. Never, ever, 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 ever do you want to see that. You better see those battery lead connections going right to the battery. If you don't see them going to the battery, that owner will have a magical boat. Magical boat. The owner will turn off the battery switches and the lights will be on and the water pumper will run. And if you are not worried by that, congratulations, you have no problems in your life. Because if my house was disconnected from the water main and I was able to actually have flow on the tap, I would freak the hell out and I'd be running for my mom. I'd be like, I live in Satan's house. How could I be disconnected from the water main and have water coming out of my pipes? It's impossible, unless you have a battery charger that is, connections are switched. A world of hurt. So a lot of people will actually, and remember, a battery switch, there's a load side and a battery side. So if they take off a battery switch, like for example, bayliners, the connection's right there. Where do you put it? You put it on the left, put it on the right. You know, and most people, it works, right? That's the problem. Remember, electrical is a world of perfection. It's like being in software. If you're in software and you don't care about details, you are in the wrong business. Your code will never compile. You will be fired on day one. It's over. You are out. Being an accountant, same thing. If you don't care where the decimal point is, you're like, I'm so sorry. I know you have all the right numbers, but the decimal matters. Out. Electrical, same thing. You don't care where the connection goes, get out. But this is a world of boats, and there's not a lot of people surveying or managing the workers, and the bar is very, very, very low. So charger connections can never, ever, ever, ever be switched. They have to be unswitched. Battery charger size. Here's a universal truth. 99.9% of all manufacturers follow this rule. They size battery chargers to be 10% of the deep cycle battery bank. Meaning, if you have a battery bank of deep cycle batteries that is 400 amp hours, the builder will have put a 40 amp battery charger. Honestly, this rule has been followed by pretty much all engineers, all builders, all time, without exception, I don't think ever. Everyone knows it in an engineering department at a builder. The moment the boat leaves the building, the manual does not explain why the engineer chose what he chose for that boat, because the manual will go from this thick to this thick. And nobody reads the manual to begin with, so they can't tell you why we do things. They can only tell you what we did, right? That's the reality. And people end up adding more batteries, and they increase the battery bank size, and they never think about increasing the battery charger size. So the rule is this: it's got to be 10% of battery bank size as a charge rate. If it isn't, welcome to a world of hurt. Your batteries are never going to last as long. You're going to be changing batteries every 2 years, 3 years. And remember, boaters are not stuck as boaters. They can have another hobby: an RV, a cottage, an airplane, saving money, vacations, trips. And we got to keep them with less frustrations. It's expensive enough as it is, even if everything was done right. So battery banks being changed every 2 to 3 years is simply unacceptable. It's frustrating, it's disappointing, and that's because most chargers are undersized for the bank that is currently deployed on the boat, because someone made an assumption that the engineer in 1982 sized the charger for all permutations, all sizes of battery banks in the foreseeable future. And even if you have a boat that was built in 2012, the battery banks today are bigger than they thought they needed them back then. Every year, the banks are getting bigger. So if you think the battery chargers are the right size, think again. They're always undersized. Yeah, the wrong argument, because the problem is during bulk charging, you need enough energy, right, at the right rate to re-energize most of that battery bank. And if you don't have that right rate of charge, you'll energize 99% of it. And the next time you charge, you'll charge 99 of 99. And it's sort of like a nice gradual slow death. It's not a sudden death. It's not like you were feeling an 18-year-old your whole life and then eventually you just pass out. You just feel shittier every day, like eating fast food every day. So that person can choose to do that, and I have no problem, because actually that's good for my business. And I tell owners, if you want to see me more frequently and you feel flush with your money and you feel like giving charity to battery people and myself for changing them, you do not have to follow my advice. Now, you know that I'm here. Why? Because your batteries didn't last as long as they should. Choose to ignore me at your peril. Every builder does the 10% rule. If every builder does the 10% rule, do you think that they're wrong? Builders are pretty cheap. They all have to be, because they're building to a price point. The factory did it. There's factories are run by accountants, because boat building is expensive. So yeah, the internet is full of 10%. Firefly wants 20 minimum. Battery charger settings. Unfortunately, there's not a lot of boats anymore that have just flooded lead acid batteries, right? The batteries have changed over time. AGM is pretty popular, certainly in this marketplace. 80% of my clientele chooses AGM batteries over, that's absorbed glass mat battery, which is a lead acid battery, over flooded lead acid. Why? It's maintenance free. There's no electrolyte. It can't leak. It has deeper discharge, more cycles, doesn't vent as much. All the reasons are there. The only reason people don't all do it is cost. That's a good reason. But what happens is people don't realize they buy AGM batteries and they don't actually change the charger settings. Right? How often does that happen? All the time. All the time. All the time. And some chargers are even worse than that. They have, like this one has smart, bulk absorption, which is not good, and fixed, which is a power supply. I was on a boat where they actually had bulk absorption set, and we got called on the boat after the owner had changed his battery banks, 3 battery banks in 4 years. Very frustrating. I can only imagine being his partner. It'd be devastating. Every year changing 4 AGM batteries, $2,000, time in, time out. Boat's not reliable. And the only reason is he didn't know, and not his fault. The battery charger had a little dip switch in. It was hidden, didn't know where it was, didn't know what it was doing, and it was the wrong setting. So you can set a battery charger for the type of battery. Do you want it smart, not smart? Do you want to have it temperature compensated, right? You can actually have some that are temperature compensated for cold batteries, warm batteries, hot batteries, or climates, I mean. If you don't have a temperature sensor, which most battery chargers don't, new ones do, but old ones don't, all those settings will make a difference. And if you want a happy client that has a battery bank that's going to last as long as it should, check the settings on the battery charger and make a recommendation. Another thing, just before I let go on battery chargers, and I'm going to open the floor to questions. All too often, people change the charger. Do they change the wiring to the charger? Nope. Why? Because they assume that, again, the builder built the boat for all permutations in the future. And I tell people, nobody's going to do that. Nobody built your house for 4 stories. If it's a 1-story build, it's a 1-story build. The foundation can only be for what was built at the time. You change the charger, you go from a 40 amp charger to a 60 amp charger, you're probably going to have to change the wire size. Right? And the fuse location on a charger, right? Most boats do not have fuses on a charger circuit. Most, by far. It's a complete omission, complete omission. And if they put the fuse, they're actually putting it right beside the charger. Now remember, a charger will rarely fail in charging more than it's meant to charge. But a battery has pretty much unlimited power, right? Given a choice, you better fuse at the battery, given a choice. Or fuse at both ends of the circuit if you want, but at least fuse the battery. Because the battery is, you can weld 1,000 amps through a battery, no problem. Right? And if it's gauge 10 wire, gauge 8 wire, that's a fuse to a battery. Right? No battery can take a dead short on a number 8 gauge and let that 1,000 amps go through that wire. The wire will literally melt. Yeah. And the problem is wires are bundled. So it's a domino effect, right? It's not a single wire running on a concrete floor. It's a wire running in a bundle, and when it melts the other wires in there, and they short. And then that's why you've got these boats where they've got these bundles going up from the flybridge, from the lower helm to the upper helm, the whole conduit gets burnt. And stopping an electrical fire without a battery switch? Good luck. There's just no way. That's why the battery switch has to be easily located. I tell people it's like knowing where your through hulls are. If you don't know where your through hulls are, congratulations. Again, you do not worry about a lot of things. As a boater, you have to know where your battery switches are and where your through hulls are. You have to know. You have to know. And you run for dear life for those switches if you ever smell fire. Run for dear life, because that will stop the fire, the fuel, from continuing to shorten and potentially cause a bigger fire on your boat. Any questions on battery chargers? All right, battery charger.
Just real quickly, so some battery chargers, well, I think most battery chargers have a fuse inside the battery, inside the charger.
No.
No?
No, none. Almost, I can't think. Anybody can think of one?
The little green ones inside the green circuit.
Okay. Pro Mariner, I don't think so.
No, none of them. This is about the only one I've ever seen.
Yeah, and this is old. The new one doesn't. Yeah.
So the cables coming off the battery to the charger, they should have the fuse within 7 inches of the.
100%. Question is, remember, and you're going to see this on every boat, by the way. You want to show that you're an expert in marine electrical. The first thing to look for is look charger, look it for fusing. First, low-hanging fruit. You want to provide value to your future purchaser, and you want to show them that I know what I'm doing. Here's something that's wrong that could cause a fire on your boat. Guaranteed, 90% success ratio, you're not going to find a fuse on the charger's connections. Guaranteed. There's no way. It's way above people's pay grade. They're never going to have done it because it works without it. Oh, yeah, but who reads the manual? I mean, that's incredible. I mean, nobody's going to read a manual.
Just to clarify, that's between the charger and the battery?
Yeah, correct. Add the battery. The charger connection, add the battery. So because remember, wires are bidirectional, right? And we do the connections nowadays with marine rated battery fuses. You can do them right on the post. Like it's an L fuse. There's no reason you can do a connection right at the battery with a fuse within an inch.
There's 2 options. One option to be wired direct to the
or sometimes boaters using the plunge, non-GFCI plunge. Is that exactly or not? Non-GFCI plunge for a power source.
It's going to be the same because that non-GFCI also has a circuit breaker.
The circuit breaker is on
The panel, same thing, same.
So it doesn't have to be a GFCI?
The GFCI, actually, I've read that recently that's part of the code. They want the GFCI to be the AC outlet feeding a charger.
If there's a water source
Yeah.
close to it.
Yeah.
But
But it has to be protected. Obviously, with a circuit breaker, it's just going to be upstream, right? So it's going to be double pole AC coming in or triple pole, depending on what, but most boats double pole, goes to an individual circuit breaker. Yeah, that goes to an AC outlet, which has a GFCI. Now, GFCI also prone to problems, right? It's only 5 milliamps, right? So that can drive someone a little bit crazy, right? And remember, if they lose their charger, they lose their battery bank. If they lose their battery bank, they lose their bilges pumps, right? So you gotta, there's a domino effect here. So just need to caveat that. And then, so they need to look at that constantly, right? Because if they have a GFCI, it can trip when they don't know. They can't assume that the charger is working. So it's about educating the owner.
Now, one question you would run into that way, charger's hardwired in, for example. You are going to have a breaker, but there's no GFCI.
Correct.
That's where you will with the LECs, I guess.
The new code is ELCIs, which makes a lot more sense. I think it's 30 milliamps, less accessible to nuisance tripping, right? Remember, I tell people all the time, regardless of money and time, there's no perfect boat. You had $1 billion, $1 trillion. Tell a team of the smartest people on earth to build your boat, you're making decisions, endless decisions. There is no perfect anything on earth for a boat. It's all about, you'd have 1 trillion decisions, constantly deciding pros and cons, pros and cons, pros and cons. There is no such thing as a perfect boat besides money and time. None. Perfection does not exist on a boat. It's all trade-offs, all trade-offs. You just have to educate yourself on the trade-offs that have been chosen on your boat.
so do you think it's a good idea to put a recommendation for a GFCI for power source?
It's certainly the code. My private opinion on that is different, but the code says so. Yeah, I think yes, the code says so. ELCI, I'd rather see an ELCI. If someone's going to do that, then I would do an ELCI on the boat. I like ELCIs better.
You briefly touched earlier about the chassis grounding on the battery chargers, which is also another low-hanging fruit. On a lot of battery chargers, there's no grounding lugs visible. Is that the manufacturer's decision that these do not need it, or they're internally grounded, or as surveyors, or being in those cases where there's no exposed lug for that?
Yeah, good question. The reality is most of the devices in our world are actually not even meant for boats, right? A prime example is an inverter charger from Magnum. An inverter charger from Magnum is predominantly made for the RV world, predominantly. The code, actually, you cannot actually meet the code spec out of the box. The lug that fits, the chassis ground wire that fits on a Magnum inverter charger is simply too small for the cable size. We literally have to disassemble that, take it off, and actually put a physical large cable and lug on there. That's the world of marine. You want easy, you want cookie cutter, you are not on a boat, right? I mean, that's crazy. And so I tell them, I said, well, you know, and you can't put it on the chassis if it's painted, because you're not going to have it. Paint is not conductive. So it's got to be a direct connection to the metal casing. I would certainly recommend it, and that's pretty rare because even these ones had them. They had a little nut at the top, and this is ancient. This is 20 years old, and most boats had that. Most boats had that, and now you're probably talking about the ferro-resonant ones that don't have them. Yeah, 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 yeah. So because again, the bar is sad, just sad. Any other questions on battery chargers? All right. My wife wonders how I can be so passionate about these sort of. I love the world of reliability. I'm obsessed. Yeah. So here is the single number one badly installed device on all boats, by far, number one on Earth, electrical on all boats. By far, there is no second, third, fourth, or fifth place. If you want to find anything that is badly done on a boat, go look at an inverter charger. When I find an inverter charger that is properly wired, I literally, even though it might be awkward, high five the owner. It is not 1 out of 100. It's not even 1% of the boats that I've ever been on that have a properly wired inverter charger, including from the factory. If you see an inverter charger manual, you will understand that no respectable man is ever going to read that. It was written for someone else, clearly someone not as intelligent as the installer. And the installer clearly just disregarded, thinking that the world cannot be so complicated and it's a waste of time. An inverter charger manual is no joke, about half, at least a centimeter thick. It's got 70 to 100 pages. And those are not small. It's not big font. It's normal font. It's a book to most people. And unfortunately, when you buy an inverter, not all the pieces to install an inverter are in the box. And unfortunately, most factories don't install inverters. It's an option post factory. Because if it was done at the factory, someone would have done it right. Because someone would be, there'd be a lawyer there, be like, no, this is too high risk. Why would we not do it? We know, just repeat, follow instructions, and the factory would do it. But the problem is inverters are generally done at the commissioning stage. And commissioning people have a bar that is completely different than the factory. It's just the reality. One bad inverter could make a yard or a manufacturer lose their whole business. You know, depending on how many people died, liability, who's the jury, they could go down. Could be huge amount of liability. But commissioning, it's the bar is set a little bit lower. People don't know what they don't know. So here are all the list of all the humanly possible, commonly things that are not happening on an inverter charger install. And that's a lot. And you need, remember, electrical is a world of perfection. It's not about getting 7 right or 6 right. It's about getting them all right. So let's go down the list. Inverter charger, the location. We'll start with the location. How often do I see an inverter charger located in a gasoline engine room? Too often. Why? Because it has the name charger in it. I had a charger in my engine room. This is an inverter charger, therefore it must be the same. It must be ignition protected because the other one was, and therefore this one is. There is no such thing. Haven't seen one yet. No inverter charger can be installed in a gasoline engine room, black and white. And if you're on a gasoline boat, most people think that the engine room is this mystical thing that actually somehow is vapor-proof by, I don't even know, they'll drill holes. I don't know how many of you have seen holes between the gasoline engine room and the cabin space. And let me tell you, it is like Swiss cheese. And I literally meet incredibly smart people that have done tremendously well on land. They are very successful and smart. And their inverter is installed literally in the cabin space. You can see the engine room with your own eyes. Literally see it in the engine room. And they think that their inverter is safe in their cabin because it's not in the engine room. They literally took it to the letter. It is not in the engine room, therefore it is safe. I'm like, vapor does not stop at the bulkhead because it used to be stopped there. Vapor goes in all directions. So if your gasoline engine room has been compromised by drilling holes to run cabling, pipes, electronics, transducers, the million of reasons of people that leave an engine room to go into a cabin, putting an inverter in a cabin when there's huge holes between the engine room and the cabin is a huge no-no. Now that is something you want to remember, because if you don't remember and you put a checkbox electrical okay and you have an inverter that is in a cabin space connected to a gasoline engine room, your conscience is never going to forgive you, because Inverter chargers are not ignition protected. And there is such a thing as gasoline leaks. There is no such thing. All of them are non-ignition protected. Every single one cannot be installed in an engine room or an engine room tied to a cabin that has all these holes in it. When we install inverters in a gasoline boat, that bulkhead has to be vapor-proof. I mean, literally, you have to blow air in there, and if the air comes out, it can never go in the cabin. Ever. Black and white. And that's a big deal. Not easy to do, by the way. Inverter chargers cannot be located above a battery bank. Chargers neither, right? Because the corrosive gassing of when a battery bank is bulk charging will cause this device to fail. Battery temperature location is oftenly missed. The location of that temp sensor can cause huge amount of grief. Make sure it goes to the warmest battery. Notice this can you imagine? Look at the depth on that nut. I mean, how many threads is that? One rotation? Right? They try to get it there. Installing a temperature sensor and gluing it on top of a battery box is useless because a battery has an air gap. Double pane windows are huge energy saving devices. Why? Because air gap acts as an insulator. The temperature of a battery at the top of the battery is not the same as the temperature on the side of the battery. Air acts as an insulator. So you need to either be directly connected to the terminal post, which is definitely carries temperature really well, or on the side of the battery. If it's on the side of the battery, it could fall. I've seen how many temperatures have I seen at the bottom of the battery box. It's not an ambient temperature, it's a battery temperature. And remember, batteries want to be charged at different voltages depending on their temperature. Everything is known at 77 degrees Fahrenheit, right? It's sort of like humans, it's like 21. Everything is based on 21. Batteries at 77 degrees Fahrenheit and 14.4, 13.4, all these numbers that you can think about are at 77 degrees Fahrenheit. Voltage drop, battery temperature drops, voltage goes higher. It's an inverse correlation between battery temperature and voltage. As the battery temperature or the ambient temperature or battery temperature goes high, the voltage goes lower. And you also want to measure for thermal runaway. The larger these chargers get on these boats, remember these laptops that used to catch on fire? That's called a phenomenon called thermal runaway. That temperature sensor would protect against that. If you don't have it at the right location, you could have a battery bank that catches on fire. You don't see liability. Temperature sensors are huge, huge. Inverter disconnect. Most people don't have one because it's not in the manual. Well, it's in the manual, but it's not in the box. The worst place is most people don't understand that that switch has to be directly connected to the battery, unswitched. Now that is a world of hurt if you don't do that. It cannot be to a switch connection, it has to be directly to the battery. An inverter charger is a weird device. It's both a charger and an inverter. It's a load and a charger. So the code is really big. This switch has to be going to an unswitched distribution, not a switch distribution. Again, I have all these schematics on my website. I call them conceptual diagrams. If you're curious, I show how to do that. And I have whole videos and sections where I talk about all this stuff for like an hour just on inverter chargers, like an hour just on batteries, 2 hours on every single topic, because there's no end to this. But looking for a switch is important. Inverter chargers absolutely need this switch. Absolutely need this switch. If you don't have it, it's essential that you do. The fuse. Look at this. You can't make stuff like that up. I don't have that imagination. I'm just simply too dumb. I just don't have it. I could have never solved this problem like that. I don't have it. That's an inverter fuse. Typically, it's a class T fuse, ceramic fuse. You can't visually see that it's failed, which is really good. Provide value to a client. They have an inverter, have a multimeter on board, because if you ever want to test that fuse, you will never be able to visually inspect that fuse and see if it's blown or not. And inverters are not gadgets. People really depend on the inverters. Some of them run their fridges from them, right? They run their TV, Nespressos. There is a huge amount of bonus in having an inverter on a boat. And if the owner doesn't have a multimeter, they'll never be able to tell if this fuse blew or not. There's just no way. They can't. Visually, you can't inspect it. And then remember, people go from a 2,000 watt inverter, put a 3,000 watt inverter, they don't change the fuse. How often have I seen that? Inverters with no fuse all the time. Fuse is mounted right beside the inverter. They think it's an appliance fuse. The wire completely unfused. The inverter just the last foot. They're fusing a foot of wire and the inverter. 20 feet of run, completely unfused, running, loose wiring right beside the engine. And I don't know if you've noticed, but if you start geeking out and you look at the cabling in an engine room, you'll see a lot of chafe on that cabling. Run your hand along it. You'll see tons of indentations. That's chafe. Those river rocks got round over time. They didn't start round. Right? Over time, 10, 20 years, eventually they're rubbing. And then when that jacket ever touches that engine, right, which is completely grounded, it's positive and it's unfused, it's game over. 4-aught to an engine, it is over. You run for the water. There is no even dropping a dinghy. Forget it. It's a bomb exploding in your engine room. 4-aught, dead short, you're done. You're completely done. And remember, most of them are actually unfused because there was no fuse in the box and nobody read the manual. Look at this incident here. The owner thought the cabling was defective. No fuse on the wire. The fuse literally looks like a cigar, not the fuse, the wire. Look right here. Look at this. Smoldering. Unfused. An inverter has no ability to stop doing what you ask of it. It's like my lab. She will fetch until she dies. An inverter, you have a 2,000 watt inverter, you put a 4,000 watt load, it will do 4,000. It's going to try. The fuse is there to protect the inverter from overloading itself. So if you ask a too big of a load of your inverter, it will try to do it. And if you don't have a fuse, well, then the wire is your fuse. And look at that wire. You can't make stuff like this up. You just can't. Here's an example of a chassis ground. 4-aught wire. This is a Magnum. Yeah, number 10 wire. This is a fuse now, by the way. If ever there's a dead short on this boat, that's a fuse. Now, this is way over everyone's pay grade. Notice this boat has 2 neutral buses. If you install an inverter on the boat, or someone did, they have to have 2 neutral buses. A bus for non-inverter loads and a bus for inverter loads. How many people do that in the do-it-yourself crowd? You know how you know those boats are having problems? They go to a marina in Washington State where there's actually ELCIs on the dock, or GFCI in some of the marinas are here, and they're constantly tripping the breakers. They can't plug in. They're literally going to Roche Harbor, and they cannot plug in all weekend. Their breakers are constantly tripping. And generally, we get called in, and they couldn't plug in all weekend, because in Canada, most of the marinas don't have that. You just simply plug in. You got a breaker, but you're not looking at imbalance, right, between the hot and the ground, between the hot and the neutral. And that's generally because they have an inverter on board, and whoever installed it couldn't read the manual because it's too thick. And most men, we're lucky, we're infused with knowledge at birth. So they don't have to read, because, I mean, that was written for other people. And so they don't have neutral buses, separate neutral buses for non-inverter loads and inverter loads. By the way, if the boat builder did it, they did it right. Generally, honestly, boat builders have a really high bar. This is past factory. Anything that's commissioned or done by an installer. Any questions on inverter chargers?
Yeah, one question. When you do find that, what does a person say to you
Oh, they never believe you. Yeah, the question is, what do people say when, because they're unlabeled. Neutrals on most boats are unlabeled. Only the hots are labeled, right? So you got to find, if you've got 40 neutrals, you got to find the 40 neutrals out of that, which 8 are actually on your inverter. So you got to literally go for them, find them. You're looking for 40 needles, and you got to one by one find out which one it is. Now, the only way to save yourself with that is reputation, right? You know, I'm lucky over time we've made a reputation that it's going to be expensive. And honestly, if you're not sitting down when you receive my invoice, it's not healthy. So people are used to it, but unless you earn that trust, they think you're out for making a meal. So you got to earn people's trust. That's the only way to do it. You know, you got to earn people's trust. But yeah, generally the rule of thumb is whatever you think is a fair number, double it. Yeah, and then we're in the ballpark.
Quick question for the battery isolation switch. I understand after listening to many of your presentations why you need one. Okay?
Mm-hmm.
As you're rightly saying, it's a rarity you ever find an inverter charger installed correctly. So before I make a recommendation, I try my best to try to explain to the client
Why
he needs to spend this money. And the majority of times, once you explain it to them, they're like, thank you very much, my family is safe.
Mm-hmm.
Now, so I understand why you need the battery isolation switch, but the owner says, well, all inverter chargers have the control panel, and they said you just switch that off.
Okay, all right, I'm going to go there. I love it. I love to dance. I was born to tango. I love those people. I do presentations for a living. Oh my God, love it. Bring it. What I ask people, the first question is, you're going to work on the AC on your boat. I ask every time in the room, what are you going to do the first thing before you touch anything AC on your boat? Anybody want to tell me what they're going to do before you touch on an AC panel on your boat or a GFCI? Anybody want to take a guess? What's the first thing you're going to do? Yeah, breaker or shore power? Yeah, shore power. Why shore power? Why not the breaker? Ah, because you're sure. Would you trust your life with a breaker? If you can choose to disconnect your boat and literally be disconnected, why trust something lower than that? Right? Like, why would you disconnect? Would you just disconnect it and actually leave it at the dock, unconnected, while you go back inside the boat? No, never. You take that cord, you cord it back, you put it in a locker, because you might have a good Samaritan walking down the dock thinking, hey, I'm going to come and help you. You're just going to, by the way, in the industry, there are lockout tags, right? That's what they do in the real world. Remember, the marine world is an interesting world, okay? You have lockout tags. So you take that cord, you bring it back on board, you put it in a box, and you hide it from everyone, because now you're working and you don't have a lockout tag because this is a boat, but this is your life. Now, you also shut down the breakers, right? Because just to be sure, because you might have a generator on board and that generator might have an auto start, right? And you don't want that generator to be energized. And before I would actually go to the generator, if the generator has a battery switch, I'm like, screw it. I'm not stopping the output of the generator. I'm starting the generator from starting. Turn the battery switch from the generator battery. Now, I educate people. I say, do you realize when someone programmed your remote, do you think this is a nuclear lockdown key at a silo in Idaho where the control has multiple communication confirmations with the remote between the inverter? The owner said, shut off. Acknowledge, shut off. Yes, shut off. No, this is a telephone wire. You're pushing a button. What if the signal didn't get to the inverter? This is not a double lock key. You're ready on my command, both turn left. You're pushing a button that it was 5 cents on a computer board, sending down a telephone wire to a piece of equipment that is installed in your boat that is 20 years old. And you're saying, I'm going to take a chance with that? And now here's the worst part. Inverters have a feature called load sensing. You want a world of hurt? Load sensing. 50 watt, don't turn yourself on. You're smart. You take your little magic wand, you go to the AC outlet, you're like, look, no power. You put your GFCI tester, you plug it in the outlet, no power. You're like, I'm good. My inverter is off. I'm smart. I did 2 tests. But you didn't realize is none of those tests were more than 50-watt loads. Your inverter has an ability to disable itself unless it senses a large load to save power. You disconnect your outlet, you touch the neutral and the hot. By the way, this is more than 50 watts. The inverter goes, hey, suddenly we have a load. Turns itself on, you electrocute yourself and you die. Your choice. Put a switch on, which is what the manual says, or do it your way and welcome to world. I hope you have good life insurance and you're not loved, right? And that's the reason. And if they're not convinced at this point, honestly, this would be a good exit strategy because they're just, not everyone should be voting. Let's be honest. And those people are not my clients.
So basically, it's a double safety.
Well, it's a fuel shut off. That's why you do it. And I was in the room when they did the code, but as an engineer, I'm going, it makes so much sense. We're doing it with everything else, right? And that's the reason. And I wasn't even in the room. Power of deduction. And remember, that's the hard part about manuals. They only tell you why, and it's 100 pages. Imagine if they told you what. I mean,
on that same thing, on which ABYC standard is that? You know what I mean? Is that just the generic one that it's over 800 cranking amps? That's what you put in there? Or is
Sarah, do you know? But that's a battery, so we're talking about an inverter charger. Yeah, I'm talking about an inverter charger battery switch right now, right? We're talking about inverter charger battery switch.
Yeah, I know. I mean, I like to put the ABYC while you have it, and for the love of me, I cannot find the ABYC standard. I know it's a standard because it's on the diagram.
Who knows here?
It's in the diagram. I'm sure it's in the diagram.
Yeah, it's in the diagram, but most of the diagrams they point the arrow to it and they give you the standard. But
Yeah.
on the ABCY, on the diagram, it shows you the battery switch, but it doesn't tell you which standard.
Yeah, I don't know that one. Don't know that one.
I have a cheat sheet somewhere. There you go. Anyway, so if anybody knows, it'd be great. Thank you.
Sarah, what time do we finish in 5 minutes?
Yeah, 5 o'clock.
I'm going to skip a battery monitor. Well, just really quickly. The location of a shunt is essential when you see a battery monitor. It's not a code thing, but if you're looking at it, make sure that nothing negative bypasses the shunt. Otherwise, it's badly installed. How many battery monitor shunts are badly installed? Easy over 50%. Easily over 50%, meaning they have batteries that have, I have people that have refrigerators that don't draw power. They're miraculous power. Their fridges never draw power. Unrelated though, their batteries die too soon. I have people that have heaters that draw no power. They're convinced. They're like, look, my battery monitor tells me it draws no power. I'm like, congratulations, you have a miraculous heater. It's amazing. You're very fortunate. Or potentially your battery monitor doesn't capture your heater loads. Which one are more plausible? And you're calling me here because your batteries die quickly? Which one do you think? Is it because your fridge doesn't draw power, or is it because you don't count your fridge as a load within your battery monitor? All right. This one is amazing. I'm going to close with this one because this one is really cool. Battery combiners. Great and terrible device at the same time. Battery combiners are the ability to put your batteries into parallel automatically whenever they sense a charging voltage. Meaning it's like a human turning a switch to all or on off parallel whenever they sense a charging voltage, which is great. It's great. The problem is most people don't realize that when 2 battery banks are put in parallel together and they're uneven levels, the current going between those 2 battery banks is not limited by the size of the charger or the size of the alternator. Meaning that you can't say, and you'll never know what is going to be the maximum amperage going through that wire. You'll never know. You just won't know because it depends how uneven the battery banks are, right? That's the whole principle of hydroelectric dams. The bigger the gap, the more fast the turbine turns. And what you need to be careful about as a surveyor is that these devices have direct connections to unswitched distribution. They have to go to unswitched. If they go to switch, that owner is going to be a world of magic. So it has to go directly to the battery or to a connection that is always connected to the battery. And it has to be fused, not here, and I see this all the time, a fuse here and a fuse here. They're literally protecting a device this big. The fuses have to be at the beginning of the circuits, and they have to be able to handle the maximum amperage that the device can handle. So if this device is 120 amps, the fuse cannot allow more than 120 amps to go through there, and the wiring needs to be able to handle 120 amps. And what you'll often find on a boat that's being sold is a boat that's not being loved anymore, generally, you know, is that one of those fuses is going to have blown, and the thruster battery bank at the bow of the boat is going to be completely dead. And the reason it's dead is because the fuse blew. So if you want to be a hero, look for blown fuses on combiners. They always blow. Because whenever you have two uneven battery banks, it doesn't matter that the alternator was only 100 amps and the charger was only 50 amps. You're like, well, how would something blow if I don't have a charge rate exceeding the maximum amperage of my chargers? It's because two battery banks were put in parallel and big differences. And when that happened, the current going through those two battery banks were way exceeding the 100 amps. The fuse blew. And unfortunately, this is not Star Trek. Nobody knows. And how many boats have voltmeters on their thruster battery bank? 1%. A Northaven? That's it? Maybe. Every other boat doesn't have a voltmeter on their thruster battery bank, and nobody knows, and they assume that they have battery voltage. So battery combiners are everywhere on boats, and make sure that they're done to code. And the other thing too is that the negative sense wire has to be fused as well, because it's actually a smaller wire, and you have to put a gauge 10 or gauge 15 depending. And so that has to have a fuse, because the reference is much smaller than the positive coming in. So with that, I'll open the floor with questions, or I'll just vaporize.
So, another question from a surveyor's point of view for fuse location. Obviously, when we're doing surveys, we're not doing an electrical audit as you're doing. What I basically do, I come to something, I look at something, and with whatever knowledge I have, I go, that seems fair, we move on, okay? So when it comes to, because vast majority, especially older boats, there's no fusing or anything like that. But for a real simple thought process, the fusing should be at the start of the power, which is normally around the batteries.
Yeah.
So basically, any wire which is kind of coming off the batteries, apart from the starter battery, everything coming off the batteries, they should have fuses somewhere in that general vicinity.
That's I think, a good rule of thumb. Absolutely. And the large majority of boats, I mean, I'm not sure if everyone heard the question. You know, I mean, and this is what's so hard about this world, right? We're expected to be experts in all things. And as surveyors, you have to know everything about a boat, which is, I mean, an ideal, but 1,000 years and you'd still be learning. It never ends. I mean, it's just a huge field. So if I'm putting myself in your shoes, I mean, my job as an electrician or as an engineer for electrical is easier because that's all I do and only do. If I was in your shoes, and I agree with that good statement, look at the battery, right? Look at the battery bank and look for telltale signs of additions. You will clearly see things that do not look right. Regardless of your technical background, you'll see different levels of workmanship. You can tell by workmanship. I can tell right away if things are done neatly or not neatly, and tradespeople have different habits of doing things. You'll clearly see what was done by the factory and not done by the factory. Obviously, it's going to be easy. One's going to be messy, the other one is going to be organized. And then look for those cables that are messy, that are not neat, right? Those are the first ones you look for. Because someone who is not neat or perfectionist generally has tons of other problems with their workmanship. So you're looking, the first thing is, are they not disorganized or not neat in their work? And if they aren't, there is a very high likelihood that they're not perfectionists about everything else. You look for that. Anything that looks not neat is generally you're gonna find a problem. It's like where there's a fire or smoke, there's a fire. And then you look for any wire near the battery banks that looks like it's addition from factory. And 9 times out of 10, there's going to be no fuses there. And the owner will tell you it's okay because I have a panel. But you're like, no, this is the source. Nothing can bypass. Yes, your loads from the panel out to the leafs or the loads are fine. But anything that bypasses the panel, starts at the battery, has to be fused at the beginning of the circuit. And the only exception is the starter. Here's another thing about a starter. How often are you seeing the protective cap on a starter, right? Pull back, brought down. How often? 90% of the time? Exactly. Why? Because people don't understand. I'm getting chills thinking about it. How many times is the alternator post, which has a cap on it, is also pulled and all the way down? Now, do wires shear off these posts? Absolutely they do. Right? Through vibration, you have an engine that's vibrating, and if the wire was too taut, literally over time, it will shear off and literally fall off with the lug on it. And then the whole engine is what? All negative. There's no fuse on the circuit. The switch is in the engine room. It's done. It's gone. It's TNT. So that's the reason why you worry about fusing. And if you don't put a fuse on a starter circuit, I'm like, okay, you're going to drive without headlamps. You're not going to have a seat belt. You don't have a tail light. And you got summer tires in the winter, and you're driving a snowstorm. All right. Okay, let's drive carefully. You know, if you've got an unfused circuit, put the protective boots. Make sure the cable has no chafe along the whole length. Make sure it's not running along the engine, because people bypass. They put a new engine battery, then they put it over the engine. You see them, they're rubbing on the engine mounts. They're welding cable that peels off, right? You've seen old welding cable. Like the jacket actually starts cracking, like literally it cracks and falls off. You're like, no, you have no fuse. You have to compromise for no fuse and go, oh, and running the bilge full of oil, and oil disintegrates welding wire. The world of crazy. You can't make stuff like this up. If you were a novelist, nobody could write this stuff up. It's a pleasure boat. Any other questions? Yeah, go ahead. Yeah, I do it. Absolutely. Vibration. Oh, absolutely. Why not? You know, why not? And if it's easy, right? That's a low-hanging fruit. Great value. You educate the owner. You're like, next time you're going to have a mechanic, that boot has to be on. You have to be obsessed. It's an unfused circuit. So is your alternator, right? Your alternator on 99% of all boats is daisy chained to the starter solenoid. Daisy chained. An alternator vibrates. That whole place is a full. If you don't think that thing vibrates, put your hand there and you'll be numb in 5 minutes. That engine is, and that thing is, I've seen it. The wires literally shear right off. The lugs comes right off, and then it's hanging in space. That's why you need that protective boot. Oh yeah, 100. Everything 4. And how many of those have connections? It's just, you can't make stuff like this up. You just can't.